Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why some sounds just make you cringe, while others are super relaxing? Even the same sound can do both for different people. Well, today we're diving into some fascinating research about ASMR and how our brains process eating sounds, and why they can sometimes be really unpleasant. So, you probably know about ASMR or autonomous sensory meridian response. It is that tingly feeling some people get from certain sounds or sights, usually leading to a really relaxed state. Think whispered words, gentle tapping, or eating sounds. But here's the twist. ASMR doesn't always feel good. In fact, eating sounds in particular seem to be a big divider. Some people love them, some people can't stand them. This new study wanted to figure out why that happens, and what makes the difference. What are the actual sound qualities, and what kind of visual cues make these eating sounds go from pleasant to, well, not so pleasant? The researchers in this study wanted to understand what makes ASMR eating sounds good or bad. They presented participants with eating sounds in different ways, just hearing them, seeing them, and hearing them together in a matching way, seeing them and hearing them in a mismatched way, or just seeing them. Then they asked people to continuously rate how they felt on a scale from unpleasant to neutral to pleasant. They got 96 people to take part in this experiment. They were mostly young adults, and they were all asked to listen to and watch these ASMR clips. So the way they tested this was pretty clever. Participants were split into 4 groups. One group only heard the eating sounds. Another group both saw and heard the sounds, and the videos showed the actual food being eaten in a way that matched the sounds. A third group also saw and heard, but the sounds and the visuals didn't match up. For example, you might hear the sound of someone eating something crunchy, but see them eating something soft. The last group only saw the eating actions without any sound. They were shown 8 different clips of people eating things like honeycombs, pickles, and chocolate, each lasting about 30 seconds. While they were watching and listening, they had to press buttons to tell the researchers if they were feeling unpleasant, neutral, or pleasant, constantly updating their feeling. Now, let's look at what they found. This first chart, figure 1, shows what happened. If you only heard the eating sounds, that is the odd condition, or auditory. Only, people tended to rate them as unpleasant. You can see those reddish, unpleasant colors dominating the chart. But when people could see the eating sounds happening, and it matched what they were hearing, that is the AVC condition, or audiovisual congruent, the unpleasantness went down a lot. The colors shifted more towards neutral and even pleasant greens. Interestingly, if the sights and sounds didn't match the AVI condition, or audiovisual incongruent, it was somewhere in between. And if they only saw the eating without any sound, the vis condition, or visual only, most people just felt neutral about it. The statistics confirmed this. The auditory-only group had the most unpleasant feelings. When they added matching video, the feelings became much more pleasant. Even with mismatching video, the unpleasantness was less than just hearing the sounds. This is a big clue right away. Seeing the action that makes the sound really changes how we feel about it. This next part of the figure 1C, breaks down the responses into categories: negative, neutral, and positive. In the auditory only group, a huge chunk of responses were negative. In the audiovisual congruent group, the negative responses dropped significantly, and positive responses went up. The visual-only group was overwhelmingly neutral. This really hammers home the point. They also did some deeper analysis to see where the differences came from. They found that individual differences between participants were a really big factor in how they felt about the sounds. Some people just naturally react more strongly than others, no matter the condition. This makes sense because ASMR itself has huge individual differences. Now, this is where it gets really interesting. They looked at the actual sound waves. They analyzed things like how loud the sound was, amplitude, and how rough or scratchy it sounded, roughness. They found that in the auditory-only condition, when the sounds got louder or rougher, people tended to rate them as more unpleasant, and this happened a few seconds later. It seems like certain raw sound qualities can directly lead to a negative feeling if you don't have any other information. This figure 2, visually shows that in the auditory-only condition, when the average loudness, AV, amplitude, and average roughness, AV, roughness, went up, the emotional response went down, meaning it became more unpleasant. These effects showed up about 3 seconds after the sound feature changed. This suggests that the raw acoustic properties of the sound are directly influencing our negative emotions in the absence of other cues. So, what does all this mean? The researchers suggest that when you only hear eating sounds without seeing what is making them, your brain might get a bit confused or vigilant. You might wonder, what is that noise? This uncertainty can lead to unpleasant feelings, but when you see someone eating and it matches the sound, your brain can identify the source. It is just someone eating peanut butter or crunching on chips. This real-world context helps your brain make sense of the sound, and that reduces the unpleasantness. It actively changes how you interpret the sound, shifting it from potentially annoying to neutral or even pleasant. The study also found that the link between specific sound features like loudness and roughness and unpleasant feelings was much weaker when you could see the video. This means that the visual information is taking over, essentially explaining away why those loud or rough sounds might be happening. It is like seeing the source of a loud car horn doesn't feel as jarring as hearing a loud honk when you have no idea what it is. The visual context provides a clear, identifiable source, and that makes a huge difference. This connects to a broader idea in how we process emotions from sounds. It is not just about the sound itself, but how we interpret it. Think about music. Certain chords might inherently sound rough, but how pleasant or unpleasant we find them can depend on our musical training or cultural background. Similarly, with eating sounds. The raw sound might have features that could be unpleasant, but when we see it is just someone eating, our brain reinterprets that. It becomes part of a relatable, everyday action. Eating sounds can even trigger some unpleasant responses related to our own motor systems, like a subtle unconscious mimicry. So, the visual context is not just decoration, it is actively changing the meaning we assign to the sound. Now, it is important to remember this study has some limitations because they had different groups of people for each condition. They couldn't directly compare how the same person reacted to the same sound in different conditions. Also, they didn't explicitly ask people if they could identify the sound source, so their interpretation that visual cues clarify the source remains a bit tentative. Future studies could directly measure source identification to confirm this, but overall, the findings are pretty clear. Eating sound ASMR isn't universally pleasant or unpleasant. Its emotional impact is strongly shaped by whether you can see the source of the sound and whether that visual information matches what you are hearing. Raw sound features like loudness and roughness can push us towards unpleasantness when experienced alone. But congruent visual context can override those effects, making the experience neutral or even pleasant by changing how we interpret the sound. It shows that our emotional responses are complex, relying on a rich interplay between raw sensory input and higher-level contextual understanding. A big thanks to the researchers and their assistants for doing this work. And this study was funded by the Japan Society for the Promotion of Science. It's always interesting to see who did what. Daigo, Hozaki, and Hirohito M. Kondo seem to be the lead researchers, driving the conceptualization and writing Hibiki, Okita, and Takahiro. Ezaki contributed significantly to data curation and methodology. And importantly, the authors declare no competing financial interests. If you're super curious about the raw data, it is all available online in the supplementary material. So, what is my take on this? I think this research is super valuable because it highlights how much our brains rely on context to interpret sensory information, especially when it comes to sounds that can be a bit divisive. It's not just about the acoustic properties of a sound, but about the story our brain can tell itself about that sound. For eating sounds, which can sometimes be perceived as inherently aversive, seeing the action of eating transforms it into something familiar and often benign. The fact that mismatched visuals didn't fully alleviate the unpleasantness also points to the importance of that audio-visual harmony. It really makes you think about how we process all sorts of sounds in our daily lives, not just ASMR. Even everyday noises might be perceived differently depending on what we see and what we expect. Future research could explore a wider range of sounds, maybe including non-food related noises that people find unpleasant, and see if similar audio-visual effects apply. Imagine hearing a loud banging sound. If you see construction, it is one thing. If you see nothing, it could be way more unsettling. This study really underscores the power of multisensory integration in shaping our emotional experiences. If you found this breakdown helpful, please give this video a thumbs up, leave a comment below sharing your own experiences with ASMR and eating sounds, and most importantly, subscribe to RUBIN'S Mind Lab for more fascinating science explained simply. Thanks for watching, and I'll see you in the next one.